Got it. Okay, great. So David is going to tell us about building scalable Python distributions for HEP analyses.
Okay, thank you. So actually, the last talk, in the end, the questions were a good introduction. So anyway, this is in the context, has been done in the context of CMS, but I think the ideas are not specific to a single experiment. So we were set out to try to put together and then distribute a more data science-oriented Python stack for CMS. I'll come back to what that really means. But our motivations were trying to make life easier for people doing analysis using these tools. I think, as we've seen in this conference, these tools are in wide use already, but often experiments are slow to include those in some standard distribution. But we wanted to make an option for a standard software environment. This doesn't mean that we force people to use things. It's just something, a new option. It's one way to get a common software stack across an international analysis group. And then the last thing is we eventually a lot of the analysis level work or R&D into machine learning is this example here. That will eventually turn into things you want to run across the grid. And we want to make that that's going to be hard in some cases, but we want to make that, start preparing for that. So what I meant by sort of evolving our Python stack in CMS is that sort of late last decade, we adopted Python and CMS basically for two reasons. One is to put together a job configuration language. So just a trivial example that I set up a process object and I say I want to run 10 events and I want to run from this file. And there's a whole lot of stuff I left out in the middle that's just sort of boilerplate configuration. And the second way we adopted it at that point was sort of what we called framework light, which was in some sense a hook to PyRoot that lets you load events into a Python event loop, and sometimes very slowly, because of course this is Python after all, loop over events, and then if I want to build a Z from 2 muons, I can loop over all the muons and put pairs of them together. So since 2008, Python has changed quite a bit. I think we were pretty slow relative to the evolution of data science. CMS was pretty slow in migrating towards a more, taking advantage of all the work done in Python. So that's what we've done over the past year. There's been really a massive increase in sort of data analytics techniques, data science techniques. And then I talked about, that it's easier, we're trying to make life easier for our users. And then anticipating that eventually we're going to want to use these tools in production. And our focus has often been on, making it easier to work together with different tools. Sort of data formats in and out of roots is one topic we've recently focused on. Okay, so of course you can quickly realize there's conflicting goals between sort of a person who's responsible for a software stack and an analysis user, whereas when you make a request in CMS, you make a pull request, but then you wait days before some grumpy person gives you some comments that tells you did something wrong, and you iterate through loop, but eventually your idea succeeds and you can implement the test that you wanted. Whereas if you're an analysis user, what you really want to do is go have a coffee and come back and your build is done and you can use your new idea. So we, of course, part of what we've tried to do is keep track of both of those ideas and try to satisfy them at the same time, which is of course not really possible, but we've made good attempts in that direction. So okay, we adopted pip for doing this, which our Python stack at some point predated pip, so we weren't using it in our the way we had implemented things in our build system. As we started integrating more and more Python packages, we realized that, gee, it's a lot of work for each Python package. Why don't we do something more standard such that it's, instead of 20 lines of code, it's 2 lines of code. So that was really our motivation. We're using the source distributions when we can, because it's often the only thing available. And it also makes it easy that we have our own compiler. We want to use our own compiler and things like that. It's easy to make things consistent. Okay, so apologies for people who don't speak spec file language. Hopefully that is most of you who don't speak spec file language. But I just wanted to have two slides to show you that this is ended up being very simple and lets you implement all the zillions of Python packages that people would like. There's easy to end up with hundreds of them. So you essentially have the package you want, its version, some boilerplate for your Python, for your environment variables, and dependencies. So this one happens to depend on quite a bit. And then all the limited complexity we have is buried inside a completely standard function that all of our Python packages have in common. The work is actually when somebody says, "Can I have this new package?" Is that understanding how it's set up is actually sometimes non-trivial. That to be reliable, you have to go look at what's in the setup.py file and GitHub and use that essentially. Okay. So I hid things behind this build with pip file, but I wanted to show you that it's also pretty simple. Basically, we're getting the sources on one column of code, and the other column of code we're unpacking that source tarball we got and telling pip install where I want it installed, and then there are some special cases that sprinkled along here. We can set options for building when we want to. So one nice benefit from adopting pip, which we should have realized at the beginning and we didn't, was that now users can just type pip list and they can see all the stuff that's available for them to use, the sort of free documentation that, when you're using a custom build system and other experiment tools, you usually don't have. So this was a nice feature for free. So I talked at the beginning about, of course, users have a different timescale than software releases. The way we're looking at that, how to solve that problem, is with this virtual environment Python package, which basically lets you ask the question, okay, I understand that today CMS is using this particular version of Theano, is 0.8.2. I read in my Twitter feed that there's a new one out there. Can I use it? Well, the answer is yes. So you say, I want to upgrade Theano today. You see that we're distributing an old version. So you set up in this virtual environment, which in the end is 2 lines, that it's you call virtual environment, give it a name, and then you activate that virtual environment. Sorry, it's 3 lines, because for some reason this doesn't add the Python path the way I would have expected it to if I was writing the virtual environment Python package. Then I just install using pip again. As a user, I install the version of Theano that I want. It does a little bit of work, and at the end of the day, you get the new package that you want. So the idea here is both that this gives people an easy way to modify or update what we've done, and also if they're doing analysis across the grid, they can essentially use the standard software stack that they're familiar with from the sort of C++ universe in CMS and do that with the Python universe. Okay, and then one more sort of aside is that we've also started to introduce the possibility of running controlling CMS run within Python. So in some sense, just a simple step forward from using Python for job control, that you take that process I defined at the beginning of the talk and just type CMS run and then CMS run.run. And one thing this enables, which actually Jim in the back of the room has this nice demonstration, you can define all your common blocks, a sort of common block, if you will, in NumPy, and then load that common block from a C++ code that needs the entire, say, tracking software or something like that. And why is that useful? Well, 2 examples are, say you're doing an alignment, you'd like to be able to do an iterative process within your Python script. And another one is if you want to offload your data into Spark, you can avoid multiple data loading and unloading data copies this way. Okay, so I have 3 slides just to show you what sorts of things are included. Actually, I won't try to go through these. I broke them sort of into sort of HEP developments, some of which you've heard about the last couple of days. Jupyter, which the only thing I'll say about Jupyter is why we realized that using pip was pretty interesting, because Jupyter depends on a whole stack of stuff that are all small, simple, nice self-contained tools, but then you realize you have a lot of them. The data science stack, like something like this, it's all, of course, surrounding NumPy, which is one exception where at least we're not using pip for it because we're still understanding how to get all the linear algebra libraries to work together while using pip at the same time. But the others, we're all using the mechanism I showed. And then machine learning libraries, and these are all sort of incomplete lists. But your last question should be, well, the experiments around CERN anyway are stuck on Scientific Linux 6, which certainly you're not running a laptop using Scientific Linux 6, I think. So we actually uploaded a completely trivial wrapper that if you want to say, I want the same set of Python tools on my laptop as I have on LX Plus, I can do that with pip install PyCMSSW. So an initial version of what we have is there, and essentially anyone can go use that. I mean, it's doing nothing more than taking. I depend on this list of 100 pip packages, install them all, and make them work together. You know, the hoped for benefit is that these things we should have done some validation that all the tools work together and have self-consistent options before putting stuff into this wrapper. So sort of not the latest and greatest, but things that are working well for us. Okay, so anyway, I talked about our attempt to both develop and distribute a Python software stack. We're trying to keep in mind both that users want to be able to change things quickly, put them on the grid, and at the same time we want to give folks a platform for stable and common software tools. I think one of our current activities is to both have unit tests for everything and evaluate performance so that we can know if there's a lot of tools that you can easily make them perform badly relative to what they were doing last week if you do things wrong in your sort of set of dependencies. So we'd like to have a better idea of how that works. Anyway, everything's on pip, and of course the CMS software is in any case on GitHub, so you can also see all the implementation there if you'd like. Thank you.
Yeah, I have one question. So I see this recurring theme of packaging coming up. So they heard about this Python system. There's also spec. At what point will it just simply be easier to create, HEP OS distribution of Linux?
Done that?
As soon as you can
Be
say
done.
we'll be Java because we have CMS.
There's 16 standards.
Sorry, exactly.
Be done.
But I mean, to be clear, I'm not inventing distributions.
No, I understand.
That indeed is what I want to avoid. Right? Not introducing in fact, Jim was right to mention Anaconda, which is a question to ask. That's another fine way to distribute this.
That was going to be my question. Yeah.
No, I have a question because there are a lot of people already working on Linux distributions, packaging stuff that we need, right? If we can just build on top and package only the HEP software, it may be actually easier than what we.
That was the old way of distributing software. So these are the more nimble, modern ways of distributing.
I feel like this is really built on top of a lot of the, like pip and things. I had a question though. What does the spec give you that's not available? So it's just a requirements file or something like that. Environment?
It just happens to be the way that we build components of our software distribution. And so you can, if your experiment or your build system is not talking RPM, it's just a few. It's just a few pages of spec file that you have to rewrite, which there's not much. There's not much to this in the end. If you want to turn this into a bash script, it's not that much work.
So this is also a spec file. Okay, so it's doing things like, okay.
Sebastian and Jim, you get to decide for yourselves.
Since a couple of years now, finally is everybody's you envision hybrid is now Python pretty much known, but all of the stack get
In particular, CMS's stack is not. I know the first thing we need to do is adopt techniques that don't use Python path, so that you can do some sort of transition where you support Python 2 and Python 3 at the same time. I think which is the person we had that was most interested in doing that is gone, so we're finding me or someone else needs to start working on that. That's that make sure that they sort of the interest of Python 3 is we should be there for run 3, I think. I don't know if we'll make it. Otherwise, we're going to be behind the time.
Maybe one more question, Jim?
Just actually a comment on usability. We had a HAPS, which is a CMS at the Fermilab LPC tutorial session, where we were teaching some machine learning tools and Python and such. And it was very useful having this because they didn't have to install anything beyond CMSSW. And the machines that they were working on couldn't even use HEP, actually. So having all of these modern tools bundled into CMSSW, you were able to do a whole tutorial without having all of the screens have to manage the installation.
Actually, that makes me can I ask that? So, have you? Where does Docker fit into this discussion at all? Have you discussed using Docker as a means of distributing software?
We use Docker for running on now. I was going to say Nurse, but we do have just Docker images for some production sites. We haven't tried building one for this. I think it would be as simple as the lines listed on in the last talk. It's a good lead in that sense.
Okay, great.